Welcome to Programming with Cute Widgets. We are almost there. We are almost ready to implement a tree model, but we just need one more episode of concepts before we start diving into code. In Model View, we talked about already last time that we have this hierarchy of models. So we at the top have the tree model that is actually called QAbstractItem and underneath there we have table and list model. And don't ask me why list is not a subclass of table, but it isn't. The key thing is that the way that you implement a list model is exactly with the same API as you implement a tree. And one of the things that you need to answer is, how many rows do you have underneath this QModelIndex? And that's the part that is hard to understand when you get to the first time. You just want to tell that you have 22 rows, but you are asked underneath this model index. And that's for the case of the tree. Right here now, you'll see a tree from a previous example. It's actually a Q widget, as the title says, but it could have been with a model view. And let's just assume that it's model view tree here now. And what the view needs to know is a lot of things. So the view will go and say, hey, model, there's a model for the data here. Hey, model, can you tell me how many rows do you have on the top level? And it'll say, well, I have 2 rows. See, 1, 2. Okay, cool. How many columns do you have? Well, I have 3 columns. Going well, so fine. And eventually it'll go, okay, model, at the top, you told me you had 2 rows. The second of those 2 rows, how many children does that have? Well, it has 9. Okay, cool. Hey, model, you told me that at the top there was 2 rows. The second of those rows, how many columns does that have? Well, there's still just 3. Okay, hey, model, you told me there was 2 rows at the top. The second of those rows, you told me there was 9 children underneath. I would like to know the text of the first row underneath that item there in the first column, 0 row, whatever. And it would answer, well, it's sub A9. Okay, awesome. Let's just imagine we are over here now. Hey, model, from the top, at the row 1, we are 0 based, row 1, column 1, the first child, can you also give me the icon to show? Okay, and then I return this 9. And can you, blah, 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 can you give me the font, blah, 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 can you give me foreground color, blah, 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 can you give me background color, blah, 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 can you give me, and a lot of other things. And you can see the blah, 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 blah. It's not very efficient, especially if it's deep, deep down in the tree. And this is where, had this been a regular training class, I would try and shut up for something like 5 seconds until somebody will raise their hand upon the following question, which is, how do you avoid that? 5 seconds. That's hard for me to shut up that long. And your answer is? Right, you would have a pointer. But a pointer to what? Well, a pointer to the data that is behind the stage. So a pointer that is pointing to some data structure representing that satellite orbiting around Earth that I'm currently extracting data for. That's cool. But what would the type of that pointer be? And thinking a bit more, you come hopefully to realization that, well, I cannot have it to be a pointer of my data structure about satellites, because Qt and the dear people in Norway implementing Qt do not know about your data structures. So it will likely be a void pointer. Okay, so far. Follow-up questions. Have you ever experienced any problems with pointers whatsoever, and especially void pointers? And at that stage, you'll hopefully come to the conclusion that pointers are a brittle thing that you should try and avoid. And the problem with a pointer to an item in there is what happens if at some stage way later I come around and I try to access that item and it's gone. Or if I get confused and I take an index from another model, not necessarily a complete different view with other models, but just a model that had some proxy model sitting on top. Say, for example, the user clicked on an item. The QTreeView told me, hey, the user clicked on an item with this model index. And you went to the model and say, hey, but that model index was the model index for the proxy model. And you cannot give the underlying model the model index, or the pointer for that model down there. But if you do anyway, how can the model in any meaningful way protect itself against that? It can't. It is just a void pointer. And that is where, after a bit of forth and back, somebody in my classes always raises their hand and say, can't we wrap that pointer inside of a class of some kind? And that class, among other things, keeping that pointer, also knows which model it came from. And certainly we can. And that's exactly what Qt does. And I already said the word once in my previous monologue, namely QModelIndex is exactly such a wrapping around that corner. So QModelIndex is actually a peculiar little thing that is super difficult, but conceptually, just think of that any item in your tree, there is a QModelIndex that matches it. And you can look at the API for QModelIndex, and it has a number of welcoming methods that makes it not too scary. Row and column, well, the index is in a table at this row and at that column, or it's in a tree at this row, at this column, underneath this item that's represented by a parent index there. And isValid, that is when it breaks down to me. Okay, I am not native English speaking. You might have guessed already by now. isValid. What is the opposite of valid? Broken. That's at least how I think about it. And that's exactly what isValid is not. What is valid, and I have some model indexes for your pleasure here. See, I have a bunch of different model indexes here. And then I have a very unique model index here. It's from Intercity Hotel, some hotel I stole it from. Here's a bunch of regular model indexes. Each of those model indexes refer to a cell in my table, to a row or an item in my list, to a particular row in my, or cell even, in my tree. That's what all of these does. But I need to start my recursion somehow. See, I ask for, can you give me, for this parent index, the child at row, and column, can you give me some data of that? And of course, at some point, I need to start my whole traversing down. I need to ask, I can ask for, can you tell me how many rows do you have underneath the model index and represented by this particular pen? And you go and look into your data structure and figure out that that is a Sputnik or whatever that satellite was called. And then you need to know about how many screws on that to tell how many rows there is. But at some point, I need to start the whole iteration. That's this one. So these are all my regular ones. This one represents above the tree, above the table, above the list. Dear tree, how many rows do you have at the top? This represents the top. And the tree will say, well, if you come with this particular model index, and Yes, this smells like a model index where I can ask, are you valid? Are you referring to an element inside of my data structure? And where you say, no, I'm not valid. It doesn't mean I'm broken. It just means I am not a valid index into your data. I would have loved. Maybe I should, whenever I find that switch to go to a parallel universe with a time machine, I should go back and fix the API to not be called isValid, but instead it should be called isRoot. Well, not isRoot, because it's the opposite of isValid, because that's what this one is. Dear model, how many rows, that's row count method, do you have with this model index that is valid false? And your model will then say, okay, let me see, at the top I have 12 elements, 12 rows. Dear model, could you give me an index, because I need to refer to these indexes over again. Can you give me an index for the first row, the first column, with this being the parent? You know, to go to your data structure, find the first element in your data structure, figure out how you represent the first column, and that is when you return one of these. So you figure out this one is for row 0, column 0. This one is for row 0, column 1. This is for row 1, column 0, and so on. And this one, remember what that is? At top of the whole thing. Not representing any data in your data structure, but helping you start your recursion. isValid means, yes, it's one of these. Not isValid, it's this one. And the final method that you have on your model index is that you can go and ask for what was the model this one came from. And I will talk more in the future episodes about sanity checking. And one of the things I will super much urge you to do is in any of those methods where you need to do something, you will say, model index that I'm about to answer something for, are you from me? Is the model me? Is the model equal to this? If not, then somebody screwed up, and rather throw a hissy fit before you answer the question than result in a crash with a segmentation fault and a core file laying around on your hard disk. Rather have it complain, I think you did something wrong. You gave me a model index that wasn't from me. Okay, I think I already told you, but sometimes you obviously are too stupid to understand me the first time. No, I'm just kidding. I don't know you, for crying out loud. I'm just standing here talking into a camera lens hanging on my wall, so don't be offended, will you? I will tell you the same story once again, but this time getting slightly closer to the actual doing here. The code that I'm about to show you here is not code that you would be writing. It's code that QTreeView that you'll find inside of that, at least conceptually. So what you see here is that I have a table over here. This is the item above this one, remember? And down here I have my table or my tree, the root item, this one again. So it goes like this. Let's just jump down here. Dear model, can you please give me an index for row 0, column 0, QModelIndex, parenthesis open, parenthesis close. That basically is this one. QModelIndex, parenthesis open, parenthesis close is a default constructed QModelIndex and the only model index the client can create. Nowhere in your code can you write QModelIndex and something. That's a safety measurement that we'll see in the following episodes. But QModelIndex, parenthesis close, parenthesis open, parenthesis close is this one. And it's a dear model index. Dear model, can you give me an index? Row 0, column 0, this one. So this one here, row 0, that's this one here, column 0, that is A. And it will return me an index. Can you give me for, again, this one here, row 2, 1, or 0, 1, 2, and column 1, 0, 1, and that is this index here. And finally, can you give me an index for row 1, column 0 with index A? So I cannot remember, I think it was this one, but hey, it's in black and white, so you can't see the difference. For this index here, that was now my A up here. At row 0, row 1, 0, 1, column 0, that is this particular place called B. Can you give me an index for that? And here's the index for that. That is how I address throughout. And the follow-up question, of course, is, okay, so you got all these indexes and that's cool, but I just want to return the text A, B, or C, and I would like to tell it that it's in the font, yes, but unreadable, or whatever. How do I do that? And I'm so glad that you asked, because your model will have to implement, at least for the tree model, the table and the list model, the index method is implemented for you already. But for tree, you need to implement a method called index, and the index method is the one that returns one of these here, and could be given this or given one of these. But the actual data, you get to that via the indexes. So there's a method for how many rows are there. It takes a QModelIndex. So how many rows are there in your list? Well, that's whatever. I don't need this one. How many rows are there in your tree at this level? Okay, that's the row count. Similarly, we have column count, and column count also takes a QModelIndex. All the implementation, not all, but 90, this time it's actually true, 99% of the implementations I've seen just have a return 3 or return 8 or return number of columns or whatever. But you could have different places in the tree, different amount of columns. I know I'm not answering your question yet. The next, once you know the structure, how many rows and how many columns, that's when you need to go and ask. So, dear model, now I have an index. I have this index here. Can you, with this index, give me the data of this particular role? Why doesn't it just have a, dear model, I understand that you need to index somehow. Can you give me the text? Or can you give me the icon? Or can you give me, and that, it's actually difficult to explain to you without knowing enormous amount more. So just accept that we have a number of roles, and the only way you get data is that you go and ask on the model, you ask for data for a given index and a given role, and this role is an enum, and let me just find it over here. Here is the list of all the enums. So if you want to know the text, you go and ask for the display role. If you want to know that small icon that was sitting next to it, it's a decoration role. If you want to know the tooltip, it's tooltip role. If you want to know the status tip, what's this, and so on. And if you want to know stuff like the font or the text alignment, so cells can be different aligned, background role, foreground role, check state role, and so on. And these are the 12, no, I thought it was 12 there, but I see 14 different roles that the views, the QList view, the QTable view, and the QTreeView, actually not even the views, the delegates associating with those views will go and ask your model about. But I could have a view, I would still be the view. There'll still be a table, but the table view could be working together with a delegate. That delegate was one that came from me and knew about money. And it could go and ask the model underneath, hey, can you give me the amount rather than returning it through one of these roles? It could ask me for a amount role that I implemented. And I'll show you lots of examples of that later on. And if I forget, certainly over in QWidget and more, there is a lot of stuff on that. What? I missed one. Edit role, you're right. If you're from Germany, you know what I'm talking about. If you're not from Germany and have never been there, let me tell you how Germans are. And sorry for being very stereotypic here. In Denmark, when I talk business to somebody, I will be talking to them and I will be writing, Dear Peter Hansen. That's a first and surname in Denmark. And he will be writing back, blah, blah, blah. And within minutes, it will be going to Peter and Jesper. I'm Jesper. But in Germany, until the customer has used my first name, I will be using his surname. So he decides on when we can go to first name. And I didn't understand that for the longest time. So in my model, I might have a view that shows names. And because I don't have enough space, I will simply just show Herr Müller. That's a fabulous, good German name from my German books at least. Herr Müller. That's what it will say in my list or my tree or whatever. And when I double click on that, that's when I edit his name. Then it will say Dietrich Müller. And at that point, I can see the full name. That's the edit role. So the delegate will ask the model about the edit role. And then it'll set the edit role back. Then the view, whenever it just needs to render it, it'll go and ask for the display role. Ah, Jesper, this is so difficult. Why does it need to be so hard? Well, first of all, you could rewind now and watch the 2 episodes that was on the item-based. They don't go through all of these hoops here for that. Or you can find your time machine and you can go back in time to the good old days of Qt 3. I wrote this book together with my boss, and it's a practical Qt. It's a bunch of cookbook kind of items. I'm standing with the book here now, and I'm looking at the table of content. First one is widgets in general. Next one is Q slider tips. There's 2 of those. And then it comes section 3, Q list view tips. 7 subsections. Section 4, Q table. 6 subsections on doing stuff that is super trivial today. Stuff like how do I align cells in a table? Or how do I color my cells in a table? Of course, that was not supported easily. In the good old Qt 3 days back then, you would actually need to jump through a lot of hoops. These days, you implement your model. And yes, it is slightly hard to implement the first few models, but you implement a model, and in your data method, you say, okay, if you want row 20, column 7, that particular place is where I have this magic Easter egg header item, whatever I want there. That should be with a different background color, or the alignment of all the cells in column 2 should be right aligned. Well, you specify, you look for the role being asked, and you answer, well, in that case, return Qt align right for those items. Multi-threading is as easy as juggling. Just don't drop anything. Well, in reality, it is exactly as hard as juggling 20 balls, as if I have ever tried that. Take a training from KDAP to learn how to do it the right way. One final note about indexes. QModelIndex is just a regular value-based class. It holds a number of integers, int row, int column. It has that void pointer inside of it, and it has a pointer to the Q abstract item model that it was created from. Those 4 things is what's inside a QModelIndex. Nothing more. It's not fancy in any way. That is what makes it relatively fast. But it also means that if you get an index here, hey model, can you give me blah, 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 and I got an index, I should not be holding on to this model index for long, because if I keep holding on to this, I stick it into an instance variable in my whatever class, the model might change its structure underneath. And if I open this one up and I actually look inside the int row, int column, that is not updated, obviously, if the underneath model changes. And why is that not updated? Because that would be expensive. Any model index ever given out, anytime there's a structural changes, a row is inserted into your model, you would have to go and look through all of the model indexes and see whether they are affected. That would be somewhat expensive, but it's doable. There is a special class called QPersistentModelIndex, and QPersistentModelIndex is exactly not like a QModelIndex. Well, it's a QModelIndex in that it operates exactly the same way, and you can even give it to those places where you would previously want to give a QModelIndex. But the QPersistentModelIndex is special in the way that when you get one of these, and the way you get it is that you simply create the QPersistentModelIndex and give it an existing QModelIndex, and then the persistent model index will say, okay, in its constructor, it'll say, okay, let me find that model. And it'll go to the model and say, you know what? You better tell me when things changes. And the model's answer will be, really? Do I really need to? And then any of those methods that do something like inserting rows into your database or deleting something will go through its list of persistent model indexes and say, oh, by the way, there was a new column added between column 7 and column 8 underneath this particular model index here. Is that something that you care about? And then the persistent model index can update it. Persistent model index is something that goes into the advanced programming with Qt, not into the introduction to Qt programming. I have not done any, or not a lot at least, advanced or persistent model indexes in my time. So if you only take one thing away from this, it is that the model indexes you get, only hold on to them a very short time. And usually that's good enough. Okay, that's it for this episode. In this episode, we saw two very important concepts, and I urge you, despite all the bad jokes I'm likely done in here, to go back and watch this episode from time to time, because it is vital for your understanding going forward. We saw QModelIndex being the wrapper around this internal pointer, so it was super fast to go and fetch the actual data behind the scene represented in the view. And we saw that the data method has this role that you go and ask. That's it for me, just talking on a very general level. In the next episode, we will start diving into real models, and we'll implement a list model, a subclass of QAbstract list model, and see how easy it really is once we know what a QModelIndex is. And I could likely have gone by much easier, skipping all these episodes that we've had already now, and just showed you this and said, well, screw that QModelIndex, you're not going to use it for anything. And for that QModelIndex, all you need from it is to go and ask for its row, and you'll be fine. But I'm building up here. I'm building up for you to be able to implement a subclass of QAbstract item model, which is what you'll need to subclass to implement a full-blown tree. I'm Jesper Petersen from KDAP. I hope you're enjoying this series so far, and until next time, have a great time.